Hello friends, welcome to this lecture. In this lecture, we are going to look at the block diagram of a digital communication system. In the previous lecture, we looked at the general block diagram of any communication system, be it analog or digital, and we defined the term communication as the conveyance of information which may be across space or across time through electrical means reliably and efficiently. Reliability and efficiency are two primary objectives of any communication system. A general communication system is represented by 5 blocks: the source of the information, the transmitter, the channel, which represents the physical medium through which the signal is transmitted, and it encompasses much more than just being a physical channel, as we'll see today in this lecture. The channel is followed by a receiver, and finally the user of the information, also called the information sink. Now, in order to achieve the objectives of reliability and efficiency, the transmitter and receiver blocks are further divided into other sub-blocks in a digital communication system, as shown here. The transmitter block is divided into a source encoder, a channel encoder, and a modulator, whereas the receiver is divided correspondingly into a demodulator, a channel decoder, and the source decoder. The message signal, that is the information to be transmitted that has been originated at the information source, may be in an analog form or it may be in the digital form. Most commonly it is in analog form, in which case it is first required to convert this message signal into a digital form. That formatting of the message is done by the source encoder. Another very important job of the source encoder is to compress the signal by removing any redundancy that may be present in the signal. So a source encoder removes redundancy to increase the efficiency in the communication, which is one of the primary objectives. Now, once all the redundancy has been removed from the signal, the channel encoder introduces some amount of redundancy back, but in a controlled fashion in order to increase the reliability. After that, the signal that we receive here at the channel encoder output, which is in the form of bits, which is a digital signal, it needs to take a physical form for transmission through the physical medium, and converting that digital signal into an analog form is done by a modulator. So it is important to note that the output of the source may be an analog one or a digital one, but the source encoder output is essentially a digital one, which may be represented by binary digits or bits. The output of a channel encoder is also digital, represented in bits. But the output of a modulator is always a waveform. It's analog in nature because that can only be transmitted through the channel. At the receiving end, the received waveform analog signal is converted back to the digital form. An operation that is inverse of that of modulator is done in the demodulator block. Then a channel decoding operation takes place, which is the inverse of channel encoding operation. And finally, source decoding operation takes place, which is the inverse of the source encoding operation, in order to get the best possible estimate of the transmitted message signal. The source encoder block may be further subdivided into a sampler, a quantizer, and a discrete coder. As I had mentioned, the original information may be in an analog form, which is continuous in time as well as continuous in amplitude. And for digital communication, it is required to convert this analog information into a digital form. And therefore, we need to discretize the signal in time as well as in amplitude. So discretization in time is achieved by means of the sampling operation, and discretization in amplitude is achieved by means of a quantizer. So what we receive here is a digital signal. Digital signal, which is discrete in time as well as in amplitude. And then this digital signal is encoded in the form of ones and zeros, and the output of this discrete coder is represented in bits. Here we may also apply some source compression algorithms that we'll study in information theory part in order to achieve the desired compression by removing the redundancy. And then it goes into the remaining part. It is very important to understand here that if we go back to the previous slide, if we are looking at the output of the source encoder, which is in terms of bits, and then we look at the source decoder, whose input is it in the form of bits. So if we are looking at this boundary, what goes into this boundary is a bit stream, and what comes out of this boundary is a bit stream. So this entire thing can be thought of as a channel. So I had told earlier that channel is an abstract term. And here, if we are studying source encoder and decoder, then rest of the things that is there in this can be thought of as channel. And then this channel is a digital channel, indeed a binary channel, because what goes in is a bit stream and what comes out is a bit stream. Similarly, if we are looking at the channel encoder decoder block and we want to study this part, then again this entire thing can be thought of as a digital channel or a binary channel. However, if we are looking at the modulator demodulator part, then this channel is an analog channel. It is a waveform channel, because what goes out of this modulator block is a waveform, and what comes into the demodulator block is also waveform. So a channel not only represents a physical medium through which the signal is transmitted, it represents much more than that. Its meaning also depends on the type of study we are carrying out. If we are studying modulator and demodulator, the channel is an analog channel for us. If we are studying channel encoder decoder blocks, then the channel is a digital channel for us. Similarly for the source encoder decoder. So I hope this point is clear. So now let us summarize the key concepts. A digital communication system is indeed a hybrid system incorporating analog as well as digital signals, because mostly the original signal is analog in nature. It may be digital also, but mostly it is analog. The output of source encoder and that of channel encoder, they are digital, whereas the output of a modulator is analog in form. So a digital communication system involves analog as well as digital signals, and therefore it is hybrid in nature. The source encoder improves the efficiency by removing the redundancy, and the channel encoder improves the reliability by introducing some redundancy in a controlled manner. Remember that efficiency and reliability are two main objectives of any communication system. And finally, we saw that the channel is an abstract term. For the modulator, demodulator, it is a waveform channel that is analog in nature. But for the source encoder decoder or for the channel encoder decoder, it is a binary channel, that is, it is digital in nature. Having studied the block diagram of a digital communication system, we now understand that a digital communication system in fact involves digital as well as analog signals. Then there comes a very important question to think about. What makes a digital communication system to be called so? That means, why do we call a digital communication system digital when the transmission through the physical channel is still analog? It is only a waveform transmission through the physical medium, and the system as a whole is hybrid, both analog and digital. Still, we call such a system a digital communication system. This is an important question to think about. We'll try to answer this question in the next lecture. Thank you.